When you take aim at a U.S. warship, you'd better not miss, because you almost certainly won't get a second chance. At 2:10 a.m. on the 6th of May 2026, an upgraded Khalifas anti-ship ballistic missile cleared its mobile launcher on the Iranian coast, screaming into the night sky. Just seconds after ignition, its solid-fuel rocket motor roared with fury, propelling the multi-ton mass of steel to speeds approaching Mach 10 nearly 2 miles per second. If everything went according to plan, it would slam into its designated target in less than 2 minutes. That target was the USS Carney, a U.S. Navy destroyer operating in the Persian Gulf. As the missile ascended into the upper atmosphere, its inertial navigation system, combined with GLONASS and GPS satellite positioning, began locking onto pre-programmed coordinates. The targeting data had been provided by an Iranian Mojajir 6 reconnaissance drone hovering hundreds of miles away. Before we go any further, drop a comment below. Type 9 if you stand with the United States, type 1 if you support Iran, and if you're a proponent of world peace, type 5. Now, get ready for combat. Inside a hardened underground command center about 2 miles from the launch site, Iranian operators monitored the missile's telemetry data via an encrypted military network. On their screens, the flight path looked perfect. A few officers even shared a smirk. They believed that this time they might actually land a hit on a U.S. capital ship. What they didn't realize was that the missile's inertial guidance system was off by a mere 0.4 degrees. In the initial stages, such a microscopic deviation is almost unnoticeable. However, as the missile follows a high-arc ballistic trajectory tens of miles into space toward the Persian Gulf, that error magnifies exponentially, potentially dooming the entire mission. The missile bearing down on the USS Carney was the Khalifas, an anti-ship variant of the Iranian-developed Fateh 110 series. This latest version has a range of about 180 miles and is equipped with an active radar seeker for terminal phase homing. To increase the odds of hitting a U.S. ship, Iran was forced to deploy the launcher very close to the coastline. This placed the launch site directly under the watchful eyes of U.S. reconnaissance satellites and sensor arrays. In other words, it was a massive gamble. Placing the launcher near the sea shortened the flight time and improved target lock probability. But it also made the launch position incredibly easy to detect and counterstrike. Still, Iranian commanders took the risk. In their eyes, this was the best shot they had at a Persian Gulf destroyer. It all boiled down to a game of probability. The Khalifas missile has a circular error probable, or CEP, of about 300 to 500 feet, the average radius within which it might land. Meanwhile, an Arleigh Burke-class destroyer like the USS Carney is about 510 feet long. This meant the ship would have to be moving very slowly or sitting dead in the water for the missile to have a realistic chance of a hit. If the ship increased speed by just a few knots, the probability of a successful strike would plummet. Unfortunately for the Iranians, the missile was launched at the worst possible time. Modern U.S. destroyers are powered by 4 LM-2500 gas turbine engines, allowing them to exceed 30 knots. But that power comes with a trade-off. While the ship carries roughly 340,000 gallons of fuel, running at full tilt gulps down over 5,000 gallons per hour. Consequently, the ship cannot maintain flank speed indefinitely. Furthermore, the engines require scheduled maintenance after prolonged operation. To save fuel and reduce wear and tear, ships like the Carney often switch to a mode called trail shaft. In this configuration, only one propeller is powered, while the other engines are temporarily sidelined. This saves fuel, but severely limits the ship's speed and maneuverability. And at that exact moment of vulnerability, Iran opened fire. On board the USS Carney, everything was quiet. Most of the crew was killing time during a long, uneventful night watch. The ship was making only about 3 knots, barely faster than the surrounding current. Essentially, it was a sitting duck. The early morning stillness was shattered when a target blip appeared on the air search radar from nearly 180 miles away. Initially, The ship's own radar couldn't get a solid track due to the radar horizon and poor weather conditions. However, through tactical data links and the lightning-fast calculations of the Aegis combat system, the tactical action officer quickly identified a major threat. The target was moving incredibly fast. It had the signature of an anti-ship ballistic missile, and most importantly, it was headed straight for them. But how do you shoot down a target you can't see clearly yet? Luckily for the Carney, she wasn't alone. High above the Persian Gulf at 26,000 feet, a U.S. Navy E-2D Hawkeye early warning aircraft was on station. From its perch, the plane could scan hundreds of miles of airspace. Seconds after the Iranian missile cleared the rail, the Hawkeye's massive AN/APY-9 radar dome immediately detected the thermal bloom and the rising contact. Using advanced target recognition algorithms, the system analyzed the speed, trajectory, and flight characteristics. The conclusion was instant. It was a Khalifas anti-ship ballistic missile. The APY-9 radar, rotating 6 times per minute, can track hundreds of targets simultaneously across a 3-4-0-mile radius. Every few seconds, the missile's updated position was fed into the tactical data network. The Hawkeye crew quickly transmitted this tracking data via Link 16 and the Cooperative Engagement Capability, or CEC, directly to the USS Carney. Thanks to this networked warfare capability, the ship could use the aircraft's radar data to calculate an intercept solution even before its own radar had eyes on the target. But time was running out. The crew had barely 30 seconds to react. As the Iranian missile reached its apogee, the highest point of its flight, it began to pitch its nose down for the terminal attack phase. This is known as a high dive attack, plummeting almost vertically from extreme altitude. The tactic is designed to exploit the blind cone of many shipboard radar systems as the missile drops from directly above the mast. But the Carney's protective shield is no ordinary radar. It's the AN/SPY 1D phased array. As soon as the missile began its dive, the SPY-1 radar locked on, and in that moment, the crew realized luck was back on their side. Remember that 0.4-degree error in the missile's guidance system? Over a flight path of over 100 miles, that tiny mistake had snowballed. What started as a few yards of deviation had grown into a 9-mile miss from the actual target. But the missile didn't know that. As it plummeted, its internal accelerometers detected the course change, activating the active radar seeker for the final strike. The system began searching for a target at the coordinates pre-programmed by Iranian forces. There was just one problem. The USS Carney was no longer there. Just seconds after the missile alert, the officer of the deck ordered an emergency all-ahead flank on all engines. In a combat scenario, standard warm-up procedures are bypassed. Consequently, in about 90 seconds, the ship can surge from 3 knots to over 30 knots. The 4 LM-2500 gas turbines roared to life, propelling the ship forward with massive torque. While accelerating, the Carney pulled a hard turn to bring her Mk-99 fire control illuminators into an optimal position. These illuminators are designed to paint a target with a narrow radar beam in the final seconds to guide SM-2 standard missiles, if an intercept is required. But this time, they didn't even need to fire. Seconds after the radar lock, the tactical officer realized the Iranian missile was off course. Its trajectory would take it high over the ship, not into it. About 30 seconds later, the crew saw a flash on the horizon. The missile slammed into the sea about 12 miles away. Meanwhile, the USS Carney cleared the danger zone and prepared for the next move. But first, they had to find that launcher, and that's usually a lot harder than it looks. Unless, of course, you're the U.S. military. Remember that E-2D Hawkeye circling above? It was now shifting into hunter-killer mode. Since Iran lacks a persistent airborne early warning system or a tactical satellite network like the U.S., they rely heavily on video feeds from drones to track targets over the horizon and assess battle damage. That was their Achilles heel. Because the Hawkeye knew the general direction of the launch, it began slicing up the search area and scanning the Iranian coastline with surgical precision. There were no commercial flights or civilian aircraft in that airspace, so anything flying that wasn't a known friendly was likely an Iranian drone. It didn't take long to find the first major clue. From 5 miles up, the Hawkeye's radar swept the area where the missile originated. Within minutes, the operators detected a strange signal. From 340 miles away, the radar picked up the video data link signatures of 4 Iranian drones flying in formation. These UAVs were likely Mach 6 or Ababil, 3 models standard Iranian recon drones. They weren't there to attack. Their role was simpler. Forward observers. Their job was to loiter near the target area, record the Khalifas missile striking a U.S. ship, and beam the footage back to command. If the plan worked, that video would be a perfect propaganda tool. But instead of viral footage, they were about to receive a very special delivery from the United States. However, before the counterstrike could begin, one more critical step remained. See this satellite? That's a KH-11 reconnaissance satellite, one of the most advanced keyhole eyes in the U.S. orbital arsenal. It's currently orbiting at an altitude of about 300 miles. Even at that distance, the KH-11's optics can distinguish objects as small as 4 to 8 inches. To put that in perspective, it's like standing in Washington, D.C., and seeing a sandwich on a table in New York City. And we all know those sandwiches are always smaller in person than they are in the ads. Thanks to this incredible resolution and high-speed data links, the KH-11 combined data with the E-2D Hawkeye to narrow the search. In about an hour, the missile's flight path, radar data, and satellite imagery were fused together. The result: the exact coordinates of the Iranian missile launcher. Now, all that was left was to send a welcome committee to the target. That committee consisted of U.S. Navy strike fighters. At approximately 3:25 a.m., 2 F-18E Super Hornets roared off the deck of the USS Dwight D. Eisenhower, operating nearby in the Persian Gulf. Shortly after, 2 more F-18s launched, joining the formation and establishing comms with the Hawkeye overhead. The U.S. wanted to be sure of one thing. After the failed strike, was Iran prepping more launchers for a second wave? If so, those became priority number 1. As the fighters neared the Iranian coast, the Hawkeye reported that the coastal area remained relatively quiet, with no additional launch signatures. It seemed Iran didn't plan on continuing the game tonight. At least, not until the F-18 pilots saw their cockpit warning displays light up. These alerts came from the AN/ALR-67 radar warning receiver. The nose, fuselage, and wings of the Super Hornet are packed with antennas that provide 360-degree electronic surveillance. The system can pinpoint the direction of enemy radar signals. While it can't always measure distance perfectly, the signal strength allows pilots to estimate if a radar is close or far. Seconds later, the electronic ID system detected a familiar frequency. It was the fire control radar for an Iranian Rad air defense system, tucked away between 2 civilian apartment buildings near the coast. The F-18's electronic library contains thousands of radar frequencies from around the world, making identification near instant. However, under the rules of engagement, the pilots still needed visual confirmation before pulling the trigger. That's where the belly-mounted sensor pod came in. This device is the AT-FLIR, the Advanced Targeting Forward-Looking Infrared Pod. It's a suite of infrared and electro-optical cameras that can identify targets up to 50 miles away with enough resolution to ID individual military vehicles. This precision is vital because Iran often positions military assets near residential areas. Once the targets were visually confirmed, the F-18 formation prepped for the main event. About 30 miles out, the flight lead assigned tasks. Number 1. Destroy the Khalifas missile launcher. Number 2. Take out the air defense radar. Number 3. Hit the command bunker about 2 miles away. Number 4. Fly reserve, ready to mop up any survivors. If everything went according to plan, Number 4 would pivot to destroy the UAV launch site, the place where those 4 Iranian recon drones had just returned after witnessing the failure of their attack on the Carney. This time, they wouldn't get the chance to record another frame. The plan sounded simple, but there was a major hurdle. The Iranian missile launcher wasn't just sitting out in the open or in the middle of a street. Instead, they had commandeered an old civilian air raid shelter and reinforced it as an ASBM launch position. Their process was clever. When it was time to fire, the mobile Khalifas launcher would be towed out of the bunker, set up, and fired. Immediately after, the crew would pull the entire rig back inside, protected by nearly 7 feet of reinforced concrete. This made the target nearly impossible to destroy with conventional bombs, but luckily for the Americans, the Super Hornets were carrying a special surprise, something that cuts through hardened bunkers like a hot knife through butter. If you look closely at the wings, you'll see each F-18 carrying 4 2,000-pound bombs, but these aren't your run-of-the-mill explosives. These are GBU, 3-1 JDAM bunker busters using the famous BLU-109 warhead. The BLU-109 is a standard U.S. military penetrator warhead fitted with a JDAM GPS INS guidance kit, turning it into a long-range precision strike weapon. That specific characteristic made it perfect for this job. Unlike standard bombs with thin metal skins, the BLU-109 is forged from 1-inch thick, high-strength hardened steel. This turns the bomb into a massive jackhammer falling from the sky. When it slams into a target at near supersonic speeds, this 1-ton mass of steel can punch through over 8 feet of reinforced concrete. A single bomb is enough to core through a bunker roof. But its power isn't just in the steel. Inside the BLU-109 is about 530 pounds of high-explosive tritonal. When it detonates in a confined space, the blast creates an overpressure wave that exceeds the human body's tolerance many times over, while vaporizing everything inside. Furthermore, the warhead is equipped with a programmable delay fuse. This delay can be adjusted from 0 to 250 milliseconds, allowing the bomb to penetrate the section before exploding. Before takeoff, technicians on the Ike had programmed a 70 millisecond delay. That was just enough time for the bomb to clear the concrete roof, but not bury itself too deep in the soil below. The result is a contained explosion inside the bunker. An area the size of a football field is instantly turned into a massive pressure cooker, where shockwaves bounce back and forth off the concrete walls. And at that exact moment, the U.S. Navy came knocking. Around 4:20 a.m., the first GBU-31 screamed toward the target. Guided by GPS, the bomb punched directly through the roof of the bunker, housing the Khalifas launcher with near-perfect accuracy. The hardened steel nose bit through nearly 7 feet of reinforced concrete before detonating inside. The explosion created a massive pressure wave that caused the entire bunker structure to collapse from the inside out. Seconds later, a second bunker buster hit the fire control radar positioned on the surface. Since this target was in the open, the fuse was set to instantaneous. The BLU-109 exploded on contact, turning the air defense radar into a massive fireball. Meanwhile, the third F-18 broke formation. Its target was the command bunker, tucked deep into a rock face on the edge of a coastal town. Despite Iranian attempts to evacuate after realizing they'd been made, they couldn't outrun a bomb moving at nearly the speed of sound. Seconds later, the third GBU-31 punched through the cave entrance. The following explosion erased the command center entirely. With the 3 primary targets destroyed, the F-18s beamed live strike footage back to the Carrier Strike Group Command 75 miles away. After receiving confirmation that all primary targets were neutralized, the Admiral ordered the strike on the final secondary target, the UAV launch site. That's why you see one F-18 peel off, heading straight for a shallow dirt bunker the Iranians had dug in an abandoned parking lot. But a 5-foot dirt trench offers 0 protection. A GBU-31 can punch through over 30 feet of soft earth before detonating. In other words, trying to protect a drone with a shallow dirt hole is like trying to stop a freight train with a fly swatter. We all know how that ends. Seconds later, the final explosion occurred. All 4 Iranian recon drones and their control crews were completely neutralized. Mission accomplished. The last F-18 exited its attack run and accelerated to rejoin the formation circling above. Together, the 4 Super Hornets turned back toward the USS Eisenhower. It was a successful mission, and just one of many that would follow as military tensions in the Persian Gulf continued to escalate.